Hello everybody. This is going to be a quick video for you that's just going to do a couple of problems, couple of examples here for you on the area of regular polygons. Okay, so just as a reminder for you, okay, if you want to find the area of a regular polygon, okay, you do that by multiplying the number of sides that polygon has, okay, times the area of the isosceles triangle. Okay, and remember the area of the isosceles triangles that you can create, right, is 1/2 of the base, which is usually the side length, times the height of that triangle. Remember, it has a special name. It's called an apothem. Okay, so I'm going to do this first example for you right here, and then I'm going to give you a chance to try a couple of the other ones. All right, so here is my regular polygon. This is a septagon. It has 7 sides. 1, 2, 3, 4, 5, 6, 7. Okay, so I have 7 sides. Okay, and you can see the apothem that's already drawn. Okay, so what I'm going to do is I'm going to draw my imaginary isosceles triangle in here. Okay, and they also gave me the side length, so each of those sides is 13.9. Okay, so for this, I'm just going to plug this information directly into my formula here. Okay, so the area of one of those triangles is 1/2 of the base, which is 13.9, times the height of that triangle, or the apothem, which is 14.4. Okay, and especially because I'm dealing with decimals, I don't really want to do all of that in my head, so I'm going to plug that directly into my calculator. So I'm going to do 14.4 times 13.9 and that number is 200.16, and then I'm going to cut that number in half, which is 100.08. So that's the area of one of my triangles. So the area of my polygon is the number of sides, which is 7, times the area of my triangle, because there's 7 of those triangles, right, that make up the whole area of that shape. Right, so I'm literally just going to multiply that by 7. So the area of my polygon here is 700.56. And there's no units in the problem, which means I don't need to use or give units in my answer. Okay, so the next two here are very similar. Okay, so I want you to try those two. Try those two on your own, and then check back with me to see how you did. Okay, I will write the equation for you one more time. Remember that the area of a polygon is number of sides times the area of the isosceles triangle. Remember that the area of the isosceles triangle is 1/2 times the side length times the apothem. Right? So just base and height. All right? So go ahead and pause the video, give these two a try, so part B and part C, and then check back with me to see how you did. All right, folks, so go ahead and check your answers for those two against mine. So for the first one, part B, that is a pentagon. It has 5 sides, and they gave me that the side length was 7.5, so that's my base, and then the apothem was 5.1, so that's my height. So the area of one of those isosceles triangles is 19.125, and then I'm multiplying it by 5, and I got 95.625. Now, if you rounded at a different spot than I did, you may have gotten a slightly different decimal than I did, but that's okay. Right? As long as your process was correct, you're golden. Same thing on the next one. So this time I didn't give you a picture, I just gave you the information. I told you we're dealing with an octagon, which has 8 sides. I told you the apothem, or the height of your imaginary isosceles triangle, is 14.1, and I told you that the side length, or the base of your imaginary isosceles triangle, is 11.7. So the area of each of my imaginary isosceles triangles is 1/2 times 11.7 times 14.1, which is 82.485. You could have rounded at that point. If you did, you may have gotten a slightly different final answer than I did, but again, totally fine. Okay, so I took my area of one of my triangles, multiplied it by 8, because there's 8 triangles total, right, in an octagon, right? When you draw them this way, right, when you draw them from the center, like out to the edge, right, there's 8 of those isosceles triangles, right? And you just multiply that through, and I got 659.88. If you rounded right here, you may have gotten a slightly different value than I did. But again, totally fine. It's just because of rounding. All right, so let's take a look. We've got 2 more here, and these are definitely slightly more challenging problems, okay? So for this one is a challenge because they didn't give me the side length at all, but this is another one of these places that I can use my knowledge of right triangles, okay? So this is a hexagon. It has 6 sides, right? Hexagons have 6 sides, okay? And because you're dealing with a hexagon here, right, this is one that I'm just going to let you know, and it's a good thing to remember, that this right here is a 60-degree angle. So you may need to use your knowledge of special right triangles. So if I did not teach you special right triangles, then it's very unlikely that you will see a problem like this. This is definitely more of a challenge problem. Like this one and the next one, definitely more of a challenge problem here, okay? But I'm going to let you know, if you use your knowledge of special right triangles, or you could use your knowledge of trig, right, to find this, but you'll get that this value from here to here is 4. Okay, which means that this whole side length is 8. Okay, because remember, again, you're dealing with an isosceles triangle here. So this apothem, this height, is going to divide that side in half. Okay, so now I have enough information that I can find the area of this hexagon, right? So the area of my triangle would be 1/2 of the base is 8, and the apothem is 4√3. So what I'm going to do is just leave the √3 out on its own, right? Because you can't multiply numbers that are inside of a radical with numbers that are outside of a radical, right? So 8 times 4 is 32, right? And then you cut that in half and you get 16. And then you have to remember to stick your √3 on the end. So the area of one of my triangles is 16√3. So that means the area of my polygon is going to be 6, the number of sides, times 16√3. So again, this becomes one of those places where you can't multiply the 3 through, but you can multiply the 16 and the 6. So 16 times 6 is 96, and then I have to remember to stick my √3 right there on the end. Okay? All right, so definitely more of a challenge problem, but not super challenging if you remember either your special right triangles, or you could have found this using trig. Right? Okay, so the last problem, again, definitely more of a challenge problem because we're dealing with a regular hexagon, and you have to work backwards. So this is asking us to find the perimeter of a regular hexagon with an area of 54√3. Okay, so I'm going to have to work backwards. So I know that my area is 54√3. So that has to equal the number of sides, which is 6, because this is a hexagon, times the area of one of my triangles. Okay, so what I'm going to do is divide both sides by 6 so that I get the area of one of my isosceles triangles. 54 divided by 6 is 9. Okay, so I have 9√3, okay, is the area of one of my triangles, right? So then what I'm going to do is plug that into, I'm going to plug that into this equation, because the goal here is to find the side length, right? So that way you can use that to find the perimeter, okay? So what I have here is 9 root 3 equals 1/2 of my side length, which I don't know, times my apothem, okay? Which I also don't really know, which is partially a problem, right? But I'm going to be able to figure it out, again, using my knowledge here of, using my knowledge of either trig or special right triangles. So I know that the area of this isosceles triangle, this whole thing, is 9 root 3. I know that this is 60, okay? So what that means is that this number here, like this height right here, is going to have a root 3 on it. Like it's going to be some number times a root 3, right? So let's do a little bit of math here, and then we're going to use this to kind of help us figure this out. So what I'm going to do is I'm going to multiply by 2 on both sides. Okay, so what I end up with is 18 root 3 equals my side length times my apothem. Okay, I know my apothem is going to have the root 3 in it somehow, right? So what I'm going to kind of do for myself is be like, okay, I know the apothem has to have the root 3 in it. So the side length times some number is going to give me 18, because I can get rid of the root 3 because it's going to be included in the apothem. And that some number that I'm looking for is this number that goes in front of the root 3. Okay, another thing that I know is that because I'm dealing with a special right triangle, like a 30, 60, 90 triangle, that this number, this question mark number, and whatever this number is, have to be the same, right? This number, my question mark number, is half of the side length, okay? And they have to be the same, right? So you have like this and this, right? And 2 of those question marks, my side length has to be 2 of those question marks, right? So essentially what I have is 3 of my question marks, because I have 2 question marks here and 1 question mark here, equals 18, right? So that means my question mark length has to be 6. Right? So we can go back and use that. So now I know my side length is 12. So that means my perimeter is 12 times 6, which is 72 units. Okay. This, honestly, you guys, is like a really, really tricky, like work backwards problem. And you have to have a lot of knowledge of either trig or really the special right triangle is going to help you out more. Rarely, if ever, would you see an example problem or like a problem like this. But I wanted to throw it in here as a slight challenge, maybe for some of my people that want something a little bit more of a challenge. So if this kind of went over the top of your head and you're like, wait, what are you talking about? Don't worry, you're not going to see this kind of thing very much. The problems that you're more likely to see, honestly, will be ones like these top 3 that we did up here. Okay. All right, you guys. So that is it for this video, and I will see you in the next one. Bye, everybody. Pause, y'all, real fast. Sorry, I realized I did this math incorrectly for number 6 here, because I forgot to, I logicked incorrectly. My apologies. So this question mark number that I have right here should have been 3, like the number 3. Okay. And that's my fault, because I forgot that I had already multiplied by 2 over here, right? And that's my bad, right? Because again, the goal here is to get the side length times this hypotenuse, or not this hypotenuse, this apothem, to be equal to 18 root 3, right? So in order for that to happen, it really should have been 6 times 3. So my side length down here would be 6 total, making this value right here 3. Apologies, guys. I realized this after I completed the whole problem, that I made that little error right there. So the logic that I used is still sound. It's just that I forgot about this multiply by 2 that I had already dealt with here. Okay. Right. So my side length really should have been, so my side length here really should have been 6. And my question mark here is 3. Right? Because 6 times 3 gives you 18. Right? So really my side length is 6, which means my perimeter is 6 times 6, which is 36. Sorry about that, y'all. This is what happens when I forget about this times 2 right here. All right? So that really is it. Bye, and I'll see you in the next video.